To describe the extreme edges of modern physics, like the behavior of spinning black holes or even string theory, you need equations that bridge the gap between gravity and quantum mechanics. In 1913, a 23-year-old shipping clerk in India produced the mathematical foundations for these theories, decades before the existence of modern supercomputers. Back then, the elite epicenter of mathematics was Cambridge University. Scholars like Godfrey Harold Hardy spent their entire careers there, building mathematical proofs through rigorous, excruciatingly methodical, step-by-step logic. Then, the morning mail arrived. Hardy opened a letter from a stranger who had no university degree and no formal training. Inside were pages filled with formulas so dense and unconventional, they looked almost completely alien to the European academics. One calculation in the letter claimed that adding the sequence of all positive integers, 1 plus 2 plus 3 plus 4, all the way to infinity, results in a negative fraction, negative 1/12. Hardy initially dismissed the package as a prank, but as he and his colleague John Littlewood stayed up until midnight poring over the pages, they reached a different conclusion. No one could invent these formulas as a joke, because no human being possessed the imagination to fake them. They had to be true. A man entirely cut off from the global academic community had somehow deduced the correct answers to deeply complex problems, and he had done it without showing a single step of his work. How does a mind achieve that? Srinivasa Ramanujan was born into a poor, strict Brahmin family in South India. The rigid structure of standard education repelled him. He disliked standard schooling so intensely that his parents hired a police officer simply to escort him to class. At age 16, he found a study guide containing roughly 5,000 mathematical theorems, but the book offered 0 explanations and 0 proofs. It simply listed the final answers. For Ramanujan, this was an advantage. He had to invent entirely new mental pathways to connect the raw problems to their solutions. By his early 20s, he was a college dropout, working as a shipping clerk at the Madras port. While tracking cargo during the day, he spent his spare time filling worn-out notebooks with entirely new branches of mathematics. He did not view his process as human invention. As a devout Hindu, Ramanujan credited his mathematical breakthroughs to his family goddess, Namagiri. He stated that an equation had no meaning to him unless it expresses a thought of God. His detachment from Western academia meant he never learned the standard rules of logic that constrained other mathematicians. He relied entirely on pure, unguided intuition. After his mother had a dream telling her to allow his departure, Ramanujan boarded a ship to Europe. When he arrived in London, the culture shock was jarring. He wore slippers in the freezing English winter because Western shoes injured his feet. When he finally sat down with G.H. Hardy, two polar opposites collided. Hardy was a strict atheist who demanded absolute methodical proof for every mathematical claim. Ramanujan was a deeply religious man, pulling complex answers out of thin air through pure instinct. Once, Hardy visited Ramanujan in a cab and mentioned that the vehicle's number, 1729, seemed dull. Ramanujan immediately corrected him. He pointed out that 1729 is the smallest number expressible as the sum of two cubes in two different ways. He could simply see the hidden architecture inside the digits. This diagram shows the historical difficulty of calculating pi, the mathematical constant representing the ratio of a circle's circumference to its diameter. For centuries, mathematicians relied on formulas requiring millions of complex fractions just to verify a few decimal places. Ramanujan tossed those methods out. He drafted an equation where a single term instantly gives 8 correct digits. Decades later, modern supercomputers would use his specific methods to calculate pi to millions of digits. While the greatest minds in Europe required a tedious map to navigate their way through mathematical problems, Ramanujan's mind simply teleported to the destination. But just as Ramanujan was reaching his academic peak, World War I broke out. The Cambridge halls emptied, and Ramanujan found himself isolated in a cold, unfamiliar country. His strict religious vows meant he maintained a vegetarian diet and only ate food he prepared himself. But under wartime rationing, fresh vegetables disappeared from the markets. He was forced to survive on little more than rice flavored with salt and lemon juice. The extreme cold, total isolation, and severe malnutrition broke his body.
He fell ill with tuberculosis and slipped into an agonizing depression, burdened by endless physical pain. In a moment of despair, the genius who could calculate the fabric of the universe stood on a London Underground platform and threw himself in front of an approaching train.
A guard pulled the emergency brake, and the train screeched to a halt just inches away. The same cultural boundaries that allowed his mind to flourish unconstrained in India were now literally starving him to death in the West. Shortly after surviving that attempt, Ramanujan received a bittersweet triumph. He was elected a Fellow of the Royal Society, placing his name alongside historical figures like Isaac Newton and Charles Darwin. But the recognition could not repair his health. He returned to India to be with his family for his final days. Even as his body withered, he continued frantically writing out new equations from his bed. His final scribbles contained what he called Mach theta sufficients. These formulas were so cryptic that it took the global scientific community almost an entire century to fully decode how they worked. On April 26, 1920, Srinivasa Ramanujan died at just 32 years old. Before he passed, he told his wife he believed his name would live on for 100 years. He underestimated his own impact. Physicists continue to use his handwritten equations to map the behavior of the cosmos. Ramanujan demonstrated that the most complex secrets of the universe are accessible to a mind willing to look directly at infinity.